Okay, let's take an alternating series problem. So let's plug in n equals 2. If I plug in n equals 2, I get negative 1 to the first, the square root of 2 minus 1. I plug in n equals 3. I get negative 1 squared over the square root of 3 minus 1. I plug in n equals 4. I get negative 1 cubed over the square root of 4 minus 1. N equals 5. The last one I'm going to do is equal to negative 1 to the fourth over the square root of 4 minus 1. So this is negative 1 radical 2 minus 1. This is plus 1 radical 3 minus 1. This is minus 2. I'll just do radical 4 minus 1. I don't care, but everybody knows that that's equal to 2. This is a 5 over here, not a 4. So this is a plus 1 over radical 5 minus 1. So that feels very alternating series. So let's first check the limit to make sure that the last term is in fact equal to 0. Not a L'Hopital's rule candidate. No reason really to multiply by 1 over radical n. Numerator is 1. My denominator is going to be very large. So therefore this is 0. That's a check. Second part I need to do is I just need to write down that in fact I've discussed that it is decreasing. It's decreasing. I've already tested you on decreasing, so we're good. The next thing is I need to show that the series without the alternating converges or diverges. I'm going to do a limit comparison test to 1 over radical n, or n equals 2 to infinity. This is divergent p equals a half, which is less than or equal to 1. P series. So now I need to do limit comparison. So let me make sure I have enough room here. Looks like I don't. I'm going to slide up. The limit as n goes to infinity of 1 over radical n, 1 over radical n minus 1. I flip and multiply. I get radical n minus 1 over radical n. Multiply top and bottom by radical n, 1 over radical n. I get the limit as n approaches infinity of 1 minus 1 over radical n over 1, which is equal to 1. So therefore, this is a divergent p series, or p is equal to half. So therefore, by limit comparison test, the series diverges, and then therefore alternating series our series conditionally converges. Why does it conditionally converge? Because without the positive negativeness, this series would not converge, right? Because it diverges by limit comparison test. We did over here, we limit compares to 1 over radical n, which is a p series divergent, because p is equal to a half less than or equal to 1. Dual limit comparison test gave me 1, so therefore I know that this series also, excuse me, my original series is also going to diverge. So therefore alternating series in our series conditionally converges, because we need the plus or minuses, all the alternating, to make it so that this series does in fact converge.